Today we'll talk about linear combination. It is not that much new, but you will see that we'll start with something you already know. So you know that if you want to add, if you look at the picture, you have u plus u plus u, and then you add v plus v. So really what you have is you have your 3u plus your 2v, and that will give you your W. You start from here and here. So this is your W. So we can say that W is a linear combination of U and V. So it's a certain number of time U plus a certain number of time V. So the definition really of a linear combination is that you can decompose a vector into a sum. So decompose is really important. One vector into a sum of two other vectors. And you remember when we do the sum, we go from tip to tail. So if you want to look at this example here, down here, you see that we can express vector W as a certain number of time U plus a certain number of time V. Let's look at what it's going to look like in our picture. So by placing a certain number of vector u and v end to end, you can obtain a linear combination of vector u and v. So you see in blue, I have my vector u. I'm going to have to use it a couple of times. I'm not sure how many. So what I can do is I can draw a parallel line. So you can use your ruler to draw a parallel line that will come to your starting point. So that's going to be a certain number of time u plus a certain number of time v. So let's draw another parallel from v, but this one needs to end at the end of my vector. Now, how do I figure out how many times? So you can measure. If I measure my vector u, I can find, let's say that it's 1 centimeter. So how many times do I need to do it here? If I measure and I have 3 centimeters, then how many times did it go? You would do 3 centimeter divided by 1 centimeter. So you know it goes 3 times here. So 1, 2, 3. It's not always going to be an integer. Sometimes going to be a decimal. So this is for my vector u. I'm going to do the same with my vector v. If I take my ruler and I measure it, it measures 2 centimeters. Now let's come here and measure this. Measures 4 centimeters. So if I take my 4 and I divide by 2, I find out that it's gonna be able to go 2 times. So 1, 2. So how would I write my answer? I would say W is 3 times my u plus 2 times my v. So that's how you write a linear combination of 2 different vectors. We can also find linear combination using the vectors in coordinate forms. So for example, if you have vector u that has coordinate 5, 1, so if you want to see what it looks like, you can imagine I'm counting 1, 2, 3, 4, 5, 1. So let's say this is my vector u. And my vector v is 1, 2, 3, 1, 2. So this is my vector v, just to give you an idea what it looks like. Okay, now you want to find the coordinates of w if w is 4 times u plus 6 times v. So how can I find out the coordinate? Well, if I want to find my x coordinate, I can do 4 times my x coordinate. So you're going to be using the first coordinate. 4 times 5 plus 6 times 3. And that's going to give you 20 plus 18, 38. You're going to have to find your y coordinate. Okay. In your coordinate, you're going to take the second one, but it's the same rule. So you have to do again 4 times your y coordinate of u plus 6 times your y coordinate of v. So 4 times 1 is 4. plus 6 times minus 2 is minus 12. So 4 minus 12 is minus 8. So what would be your answer? The coordinate of W would be equal to 38 and then minus 8. Sometimes they will ask you to find how many times does each vector go into your final linear combination. So for example, if you know that A is 4, 5, B is minus 1, 7, and W is 10, 29. How can you express W as a linear combination of A and B, such as W is K1 times A plus K2 times B? So you have to figure out what are the two scalars that are here, what are the two numbers that will come here. Okay, so what we can do, we can use an equation. So we know W, which is 10, 29, is equal to a certain number of time A, which is 4, 5, plus a certain number of time B. So minus 1, 7. Now you remember that if you have a scalar in front of the coordinate, you can distribute. Okay, so we're going to be able to do this. Now what we're going to have to do is we're going to have to look at the x coordinate. So my x coordinate needs to be equal to my x plus my x. And then my y coordinate needs to be equal to my x plus my x. So we're going to write it in two different rules. Okay, so let's find my x coordinate. I have 10 that needs to be equal to 4k1 plus minus 1 k2. Okay, if you want, you could erase the plus minus, then just put minus here. Okay, so this is for my x coordinate. Can I do the same for my y coordinate? What would I get? So you should get 29 is equal to 5k1 plus 7k2. Now the question is, and I hope this is easy for you to answer, how to solve two equations with two variables. Oops. So you have different options. I know most of you really like comparison method, but there's also substitution and elimination. In this case, elimination is really the most efficient, so that's what I'm going to do. Okay, so let's look at this. We had 10 is equal to 4k1 minus k2. And here we had 29 is equal to 5k1 plus 7k2. So when we work with elimination, the first thing we need to do is change one or two equations so they have the same number here. So I see here I have plus 7k2. Can I do something with this to get plus 7k2? I can do times 7. So if I do it on one side, I have to do it on the other side. So here I'm going to have 7e is equal to 28k1 minus 7k2. So this is my step number 1. I have to make sure I have the same here. Step number 2. Okay, so step number 1, I times to have the same number. Step number 2, I'm going to add them up. Okay, so step number 2, I'm going to add them up. So I'm just going to make a line here. So 7e plus 29, that's 99. 28 plus 5, that's 33. K1. And what happened to my K2? They cancel out. I have 0. So you can write plus 0 K2, but really you don't have to. So here, very easy to find your K1. You divide by 33 on both sides. So you have 3 is equal to your K1. There we go. We're already done for the first one. Step number 3, how can I figure out my K2? I can use one or the other. So one or the other, I'm going to use the second one, but it doesn't matter really. So I'm going to take 29 is equal to 5 times 3 plus 7 K2. So I have 29 plus 50, is equal to 15. I bring my 15 on the other side. I have 14 is equal to 7 K2. Divide by 7 left and right. I get that 2 is equal to my K2. Found my K2. Step number 4, I'm just gonna break this here. You should check that your work is okay. How can I check? Well, when I did my my step number 3 here, I used the second rule, so I'm going to use the first rule to check. So 10, is it equal to 4 times K1 minus 1 times K2? So 10, is it equal to 12 minus 2? Yes. Okay, so yes, you can put yes here. That means that you got the right answer. Now don't forget to answer the question. What was the question again? They wanted us, so I'm going to write number 5, answer the question. They wanted us to write W as, hold on, I'm just going to go back. We want to write W as a combination of A and B. So K1 is 3 times my A plus K2 is 2 times my B. So there we go, we figure out our linear combination. Have fun!